All right, hey everybody. Today we are going to talk about quadratic regressions. So you might remember when we did linear regressions, where we had a line of best fit, or I'm sorry, a scatter plot, and we made this line of best fit, and Desmos told us the exact value of all those things we need. We're going to do the same thing, but we're going to do it with quadratics today. And so Desmos is probably the best way to do this. There's also a way you can do this in your graphing calculator, which isn't too bad when you put it in your data and stuff. But for you guys, I'm just going to show you Desmos, kind of go through one with you. There's a couple for homework for examples to mess with a little bit. So first off, remember that if you want a table here, you just type in the word table. And then I'm just going to use a set of data from your book here. So we got 0, 1, 2, 3, 4, and 0, 750. 1 is 846. 2 is 910. 3 is 952, and 4 is 1008. So you can see here that we have those points kind of showing up. I'm really zoomed out, so you can't really see it too great. But let me show you my data set. So if you want to follow along, that's probably a good idea. And then you can see my points a little bit up close. They're just zoomed out. You can't really see the shape yet, but we'll zoom back out when we are ready to go here, okay? So there's that. And then remember, when we're going to plug in this, what we're going to do is we're going to write an equation for our line of best fit. But this time we have to do it with quadratics. So you're going to write y, and you have to write sub 1. There's always going to be ones here, whatever number the table is. So in our table, if you can see that, it says x1 and y1. So we're going to just make sure that we know that that's going to be x1. And then remember, do not put an equal sign, as I kept doing wrong. You're going to use this little tilde squiggly mark, right? It's on the keyboard on here, or obviously on your regular keyboard. That would work as well. So our generalized quadratic function is going to be a x squared plus bx Oh, I need little ones on my x's. Almost forgot. Because we need to know which x's we're looking at. There we go. And then plus c. Sweet. So, here's what happens. Let me zoom in for you guys again. So I put the equation in, like so. Make sure you use this little squiggly mark. And then it's going to give me all this data, right? So, what's important here? Let me show you what's important here, shall we? Hopefully you guys are looking on your own Desmos, but we can kind of see our graph now. You know, how it's quadratic. You can find the vertex up here. That's kind of cool. So your r squared term, that's the one that tells you how close to the data set everything is. So remember, if this is closer to 1, that means that it fits the data great. If it's farther away from 1, it does not. But then down here where it says parameters, basically this gives us our equation for our line of best fit. In this case, our quadratic of best fit, not really a line. So our a value, we're going to have f of x. Our a value should be negative 7.28571 x squared. Plus, the b value is 91.3429. x, and then plus our y-intercept of 754.229. So we're literally just going to take the numbers from down here. There we go. Sorry about that. We're going to take the numbers that they give us in this little statistics box. We're going to plug them in for A, for B, and for C. And that's going to tell me what this parabola is going to look like, what features it's going to have. So then we could, we could find out what goes on if I wanted to plug in like 7. Where would the value be? I could do stuff like that. But we're just going to kind of focus on those regressions today. You have a couple for homework. Try them out. Make sure it works okay. Hopefully it'll be just like the linear ones. You guys will pick it up, no sweat. All right? Cool. You guys have a good weekend. I'll see you later.